Okay, we are recording. So thank you everybody for joining today. This is the second session that we had. So if you missed the first session that we had, feel free to check out we have a channel on YouTube. And I do have links like in the Meetup group. So I'll kind of talk through a little bit of that too, because I kind of have links for different purposes. So we'll kind of go back over that. But the net is that you'll be able to go back and you can see those later. I'm going to go ahead and bring up my video too. Forgot to do that. But today's the second session. And this is the first session where we're going to split it in two halves. So this recording is for the topic of today, which is an overview of Event Driven Ansible. So we'll go through just a bit of a background, just a level set, not spend too much time there. And then I wanted to show you an example of using Event Driven Ansible from a network point of view. So we're going to look at configuration drift. And I felt that that's kind of a use case that a lot of my customers are trying to manage through. And if you're not familiar with that term, I'm going to, we'll walk through that and I'll, create like a backdrop before we go into the demo. And in the demo, you'll see some cool things happen, as well as some links in case you would like to set this up in your own environment. There's a GitLab repo that's public facing that you can access. And there's also some other links for installing Kafka and some of the other components that are used for collecting the data from the routers, which in this case is gRPC streaming telemetry data from the routers. So all those things are not too hard to set up. And there's even ways of running them as containers and all sorts of things. So we won't go into like every permutation of that, but I'll just give you some links so on your own time you can check it out if you want to bring that up. But just keep in mind that what you see here today may look a little bit convoluted because this is really just a developer tech preview. And the EDA server, if you will, where we run the rule books from, those in the future will be a part of the platform, which is the Ansible automation platform. And we really haven't talked too much about the platform or the product that Red Hat sells, but that's where it's being incorporated into moving forward. So what you see today with all these piece parts that I have to install, that's just because of the current state. And then over time, it's going to be like a real easy install for that piece. But the outcome will be the same. You'll be able to create these rules after events are triggered to be able to create actions to respond to something. So in other words, like a feedback loop. So we'll go into that in more detail. And then once we're completed with the first part, I'm going to switch over to the study group. And in the study group, unfortunately, today Cisco is having a downtime on the DevNet sandboxes. So I created like my own environment that has really a mirror of everything that's in the sandbox that we're going to use moving forward. And kind of to the point of like my backup, if you have something else, like maybe you have a CML -P, like the personal edition of the Cisco Modeling Labs, you can create a topology there and just work from there if you have that. Or if you have something else like GNS or EVNG or something else where you can spin up Cisco routers and Catalyst switches, then feel free to use that. I would just recommend what I did is I just used the same exact IP addressing. So that way, whatever we're building in the lab guide, it would make sense for you as well. So I don't want to talk too much about the study group because we're going to focus on that on the second half. And the last part here is like for questions. Feel free to stop me and unmute yourself. Try to stay on mute when you're not asking questions, but unmute yourself and you can ask questions that way. Or you can ask questions in the chat. The third way is I created on this Discord server a chat room for us. So let me go ahead and, escape out of here for a second. Let me put this link into the window. And I also have this link on the Meetup group page. But if you haven't already clicked on it, if you click on here, you can use your browser. And if you ask questions into here, then those would be persistent. I'd be able to see them after the meeting. I think in our chat, I only see them during the meeting and I try to answer them. But if I miss something, this may be a better way. But it's obviously whatever you guys prefer. So let me just jump over here into chat, and I'll paste this in down here. And this link, again, you can use your browser or you can install the actual client for Discord. The reason why I'm using this is because some of the other options required me to have everybody's email, and I don't have that, and I didn't want to bug people and all that. So this one, you just click on the link, and you can opt to join it or not. It doesn't matter. But I would go there because it's a good way for us to share as we're running into issues and things. And then if I'm not available, some of the other folks that are also a part of that can join as well and help answer some questions. And if you guys ever want to work as teams and things of that nature. So back to here. So we'll go ahead and we'll get to it now. And then again, we'll switch gears into the study group on the second half. So I mentioned managing configuration drift. So this is something that I see that happens a lot. Sometimes folks have like their own proprietary solution that helps to manage configuration drift. So first of all, what is configuration drift? So basically what it is if you're using a particular solution to provision the platform, so in this case, network infrastructure, and that's the way that you expect to push configurations, there's always that chance that something happens. So something breaks and it causes a need for troubleshooting, and perhaps somebody uses the out-of-band connectivity to be able to access that particular device and then subsequently make a change. So when that happens, then that configuration is really represented locally as the configuration state of that device. And that'll cause a delta from whatever you expect the source of truth to be. So if that was something like a DNA center, just as an example, that configuration and source of truth would be, that database of configuration that you have access to in DNA center. So the intent there is to use that, to make changes. So if you go out of band, then you need to have, periodically a way of checking that so that you can reconcile any of the diffs or differences, between the state of the current running configuration as it is in, Cisco router, and then what you expect it to be for the source of truth. So that was just one example. There's other types of source of truth. So maybe, you have CMDB as an example through like ServiceNow that you're using, or just some database where it has all of your configurations, or it could just be, and the example of this demo is just configuration backups that were taken after the configurations were vetted through a testing process. So in that particular example, and if you look at the modules, from an Ansible perspective, we would call that the intended configuration. So when you have an intended configuration, you have something to check against. And then that's where a diff, and we'll look more into diffs later, that's where you can see like what the deviation is from the configuration state of what you intended it to be, and then what it looks like on the current running configuration. So from an Ansible viewpoint, the way that we can manage that is we can schedule to run playbooks. So this icon here is just the Ansible automation platform controller. If this were older, it could be, Tower. More people are familiar with Tower, but the controller is effectively the current, way that we would represent that component of the platform. And then this could also be just command line, right? But you would have to run this because Ansible is a push model. You go and check what the configuration is, and then if it were, and that could be like a check mode. And again, I'm kind of getting ahead of myself, but we'll talk about that as well. We want to see what the state of the config is, and then check it against, whatever our source of truth is. But we have to kind of implement that and run it, over time. So creating a scheduling that looks, and whenever it finds a change, then that could be a notification, or it could be, you run another playbook and then change the configuration back to what it was supposed to be. So in other words, like kind of managing it from like a policy where you're not supposed to make these out of band changes. The other side of this could be you're making changes from the out of band, and then you want to incorporate them, so you allow them, and that's kind of a way that you can pull off like brownfield configs and things like that. and then Ansible-ize them. So that's kind of looking at it from like the reverse viewpoint. So here, what we can do in this demo is we can use event-driven. So this way, the router can tell us that something changed. So I created like another demo where I was just shutting a port, and then the router, again, would express that as an event, and it was delivered using telemetry. And then I was able to just unshut the port if the port, if it was a mistake, right? So in this particular example, what we're going to do is make a configuration change, and then we're going to notify the NetOps team that a device config has changed, and then they can see what the difference is, and then make a decision on whether or not they either accept it or they want to overwrite that particular configuration. So another interesting detail here is it's not just like a vendor way of doing this, it's across vendors. So Ansible, again, is kind of like, a layer of automation where we abstract a lot of the nuances from these types of devices and different vendors. So when we run something like this, it would actually, effectively work the same across vendors. So it allows you to kind of normalize the way that you automate and manage configs and that type of thing, where we don't have to, use, various proprietary, vendor solutions across whatever we have in the infrastructure. So that's just another item to point out there. So that's just the configuration drift. So that's just the use case. So we want to manage that. So here's event-driven Ansible, which would provide us event-driven automation. So the three pillars here that we need to understand is the event sources, the rules, and the actions. So the source is actually not like the device. It's not the end device, like the router, switch, firewall, server, whatever. It's really the source of that data that we want to evaluate. And the way that the EDA can understand that is through source plugins. So because this is new, we don't have a ton of source plugins. But if you look at some of the Ansible blogs, current blogs, there's actually one that shows you how to create a plugin, a source plugin for the EDA. Other ones have already been developed that you can use. I'm using Kafka just because Kafka broker is fairly common just in IT in general. So most folks understand how to use that, or they had some cursory knowledge of the way that works. But there's a handful of other plugins, and that'll continue to grow. So source events could be determined through multiple different ways. But at the end of the day, like the rules is really like the key part of this. So from a rule perspective, we have a new notion of a rule book, which is much like a playbook. But in a rule book, what we're doing is we're really looking at the source and then determining in that source what the data is that maps to an event. And then in the event, we create conditions so that we can trigger an action. So normally what the action is to run a playbook. So in this particular demo, it's running a playbook that is going to trigger a workflow in the Ansible automation controller. But it could have been just a playbook that did something directly. But I'm triggering a workflow, and the particular workflow that I'm triggering is one that I used to run a scheduler against to go out and check to see if the configuration changed. And then now I can trigger it directly from EDA. So anytime, in real time when a change is made, I have that actual feedback loop. And then my action is to see what the change was and to send a notification again, to the NetOps team, and then we can work from there. So actions are primarily triggering playbooks and notifications. And then, there's other types of actions, because really this is all programmable, right? There's all sorts of things that you could do, ticketing systems, all sorts of other integrations that you could create from the actions part of this. So this is kind of the meat and potatoes of EDA. Now, the underpinnings of like what you need to do to install it and all that, I do have some links that I'll show you here in a moment, just for your reference. But this is kind of like a high level of what I did specifically for networking. So because it's networking, and starting over here with a Cisco ILS device, we have really multiple ways. I could have used EEM and like a Python script. I've done something like that that uses webhooks as like another data source that we could use. But I decided to use telemetry, and I'm using gRPC, which uses if you're familiar with like Yang data models, we have IETF, and within IETF, to point to a particular path to an object in IETF, we can use XPath. So I'll show you that in the router, and also I'll share with you a really good repo I found that has great examples of using XPath with Cisco ILS routers. But the idea there is that it's not just Cisco routers. Any of the other vendors that have devices that either have a Yang data model for IETF, or if they have OpenConfig, there's GMNI, and then that also has a way of configuring telemetry. So either one of those works. We just have to determine, okay, what is the event, and they call it a filter. And then that filter, we're looking for specific type of data. So what we're looking for is just a config change. And in the other example that I talked about before, I was looking for ports that were shut, and then we would no shut them as an action. Here we just want to see that, okay, the config changed. Why did it change? What changed? So that particular stringing telemetry comes in a format, gRPC, that we can create an input. There's an input plugin into Telegraph, and Telegraph is a collector that understands all sorts of different types of inputs, and it can convert them into JSON output. So JSON, if you're not familiar with that, that's just structured data that we use often in programmability, so that way we can either manipulate data or serialize data, so we can send it like from one device to another device, like software or machine talking to machine, but it's still fairly human readable. So I like to work with JSON, over XML as an example, which is a little bit harder for me, or it's not as human readable. So JSON's fairly straightforward, and Kafka can understand JSON. It understands all sorts of structured and non-structured data. So when that data comes in, the broker, the way that Kafka works, and I'm not like an expert in Kafka, but the part that I'm using is we create these topics. So that would create, from this data that's coming in, it will organize it into this topic that we can listen for. So in Event Driven Ansible, the EDA component that, that's the server that I installed in my lab environment, it's just listening. And when it sees the topic that has been configured in a rulebook, then it'll evaluate that data. And then in the rulebook, that's where we'll create, the conditions and the actions. So in this case, we're going to trigger, again, a workflow. It could be a job template. And in the controller, the difference is like, if I'm working from the command line and I run a playbook, in the controller, which you may be more familiar with Tower, but now it's the controller. An Ansible controller, a job template maps to a playbook. And if we want to stitch together, like we want to orchestrate running multiple playbooks, we create multiple job templates, and then we can stitch them together into a workflow. So that's where the platform is more suited for like full-blown orchestration. And then when we run from the command line, we have to do a lot more manual things to run multiple playbooks. So the controller is able to manage that better. So if I create a workflow, then in that workflow, it could be a remediation. Again, like in this case, it could be to change the config back, or to configure something else based off of what was in that configuration. And then in our purpose of this, we just wanted to do the notification and allow a NetOps team through a Slack chat ops channel to determine whether or not they want to change the configuration. So again, it's a feedback loop, and this is something that's very valuable now, because there's all sorts of operational use cases where in the past we may have been limited, again, to scheduling, or just something breaks, so we're just responding to issues. And now we're able to do this and take automation like a step further and provide like automated troubleshooting and those types of things. So so from that, I mentioned this link here. So I'm going to make these slides available after probably later today, and you'll have this link, so don't worry too much about screenshots and all that kind of stuff. But this here will be the repo of what I did to create the EDA server, and there's some links there that I mentioned earlier. There's also another repo that that is mentioned in there that we'll use later. So what you'll see is this repo here, and it has the playbooks or rule books in here, and some of the playbooks that I ran to make it work. But there's also this other repo that we're going to cover in more detail later. We don't have time today, but in this compliance and remediation and validation repo, there's a lot of moving parts. But this is what I ran already to create those intended configs. So again, the whole point of that was for me to vet out a configuration and determine that it was, a good configuration that I want to create like my golden config or my baseline config from that. And that's what we're comparing against, because when I ran that, I also do a backup of that configuration, and that's our intended configuration. So let me show you real quick. I'm sorry, I have to log in real fast. Or actually, let me log in with we have roles-based access. So if I log in with certain users, I only see not everything, so it's a little bit cleaner. Yeah, so this is all the compliance stuff, and I ran this this workflow earlier. So it went through all these steps, and we'll cover this later in another demo. But it's this last part that's particularly important for what we're doing today. So with that in mind, let me get out of here, and I'm going to go to jobs. So this is what I ran earlier, and I went through a couple iterations of actually doing the EDA. The thing that we want to see here is in this health check, it does some testing to make sure that the environment is okay. And one of the things is an IPSLA, which is kind of like a smart ping. So it determines that everything was okay. And then like the last part of this is it backed up configurations for these routers. So because we created that backup, that's what's becoming what we mentioned earlier as the single source of truth with the intended config. So that's how we know something changes. And if something changes, then it fails. And it tells us it failed because it changed, and it shows us exactly what changed. So in terms of kicking this off, what I want to show you is here. This is a terminal that's running here locally in my lab. And I've already installed the EDA. So EDA is there, but in order for it to listen, I have to run a rule book. So these are different rule books. This is the one that I use for the interfaces, like shut, no shut. This is the one for what we're doing today, configuration drift. And you can see that what it's listening for is on port 9092 is the port that Kafka uses. So it's listening for Kafka to send data on this topic. So it'll ignore any other topic. So topic is just the way that you label or tag that data, and anything that says telegraph, then our EDA server is going to listen. And then what it's looking for is if data comes in with the topic telegraph, this is a condition that says that if you see this in the payload, the Cisco iOS XE native. So what this is saying is this is like an XPath in the data that was created whenever a configuration changes. So again, I'm going to show you like how you figure these out, but it's looking for this particular data, and that's the data that creates the action, which is to run this playbook. So this controller2 playbook, and I'm sorry, like for those that we haven't really gotten too deep into playbooks yet, we're certainly going to spend like a lot more time in a study group on that piece. What's important here, let me just make this bigger. What's important here is that I'm going to configure the controller. And more specifically, what's going to happen is we're launching this job to this job template. And if you remember, I said a job template maps to a playbook. So this job template is mapped to a playbook that we're going to run in the controller, and we'll see that as it happens. You'll see this job template is invoked, And then within that job template, it's going to run a playbook as part of this action. And that is where it's going to create a notification, and we'll see the diff of what changed. So that particular playbook is actually, if I go back into this here, the second repo that we're going to cover later, it's actually a part of this. So we'll go over that in more detail again later. So this right here is kind of like the front part of this. So from where we're at right now, what I can do is take you over here so that we can see those components that I talked about before we run this. And I mentioned that we have Kafka. So that's installed and it's ready to go. This is the topic. So you configure it with the actual name. So the name here is Telegraph. And then this is Telegraph. This is the collector. So this is waiting for data to be sent. And more specifically, it's the Cisco telemetry MDT is the gRPC data that we're looking for. And then over here, we have a Kafka viewer. So this is just data that was sent previously. And you can see that if you were to clean this up, it's just JSON data. And that's kind of the value of it, is that you can send this structured data, pass it from the router, all the way to Ansible, and then be able to respond to that in the listener plugin. And then this last one here, I need to connect to the router. And I just want to show you what's going on there. So in your router, it's all about streaming telemetry. And the filter that we're talking about is this one right here, subscription 2. And the filter is what's important here. So this filter says iOS native. And if you look in the documentation, you'll see that this is for a configuration change. So in terms of the configurations, if I go back into, is everything going okay here? So I go back into here, and here's these XPath examples. These ones here are on change. So these are examples of things that, and by things, I mean operational data that changes. If anything were to change on that router, then we can point to that type of change, and then it'll send that, like we can filter to that, and then we can use that, as our trigger, of the event. And then these are scheduled things. So these are things that your router itself checks periodically. This is not like scheduling Ansible to go see, talk to the router and glean something from the router. This is just a scheduler that the router will check things periodically. And then if something were to happen that's a part of that periodic check, then it's going to send that data. That could be something like, what's the state of the neighbors, BGP neighbors or OSPF or something like that, that it does periodically, like every minute or every 5 minutes. But this one is like, if you lost the neighbor, then that could be a change. Or if the port goes down, or if something were to stop or start, then that could be a change. So when you go into here, and I'm not going to spend too much time here, you see all sorts of examples that show you the configuration for the router. And there's like just a bunch of them. So the other one that I did was the interface state change in a previous video. And then we're doing just that one that was this one right here. If the config changes, this is the one that we're using. So sorry to kind of go off track there, but here we are. It's configured here. Some of the other things that are important is you have to create a receiver. So the receiver is where you're running Telegraph. So that's what I showed you earlier. My Telegraph is on this IP, and this is the port that it's using, port 57,000 with TCP. So if anything were to happen, on change, then it's going to send it, using that port. And this is just the source address that it's going to use. And it's pretty straightforward on the front end. So you just create, multiple different telemetry configs for different things that, that you want to create events around and create, their filters. And then because we have everything up and running, I can go into the router. But I do that just so you see things change. Let me kind of move this out of the way. Move that over there. And then on this side, we want to see my EDA server. So kind of move that over here. And we want to pay attention to the terminal down here because it's just sitting there and it's listening. Again, on what we saw earlier, it's just, I'm sorry, I'm not even on it. It's just listening on this port for this topic. So to do a change, if you go into anything conft, just Cisco iOS router, it's a CSR 1000B to be exact. I'm going to go into a loopback, space there, and there's no description on that loopback. So I could put anything in there. Just so I'm not pulling any tricks, if someone just wants to actually, just say something for a description, and I'll put that in there. Just anybody. Are you out there, John?
I think we're all muted.
Well, I heard you.
Alrighty then.
You just give me anything. Just one word or something.
Anything. How's that?
All right, so let me spell it correctly. All right, so I'm going to hit enter here, and I'll exit the config, and then that should kick off things here if everything's running. If it's not running, I apologize. All right, so some stuff started happening over here. Let me make that a little bit bigger so you can see. So it's saying that the configuration changed for router 1. That's the router that we were in. And then it's running this this playbook to the controller. So that means I need to jump on the controller. Well, that was a notification that came back. But let me jump on the controller, which is this. Go to jobs. And we can see that it failed. And that's what I expected. So those things kind of happen kind of quick. So let me bring up my Slack and to the last message that came in. So this is what came in. And it's like a cross-link back into the automation platform. So if I was in the NetOps team, I got that message that comes in, and then I click on that, it gives me a cross-link, and then I can see here that that something changed. So as we move down here, we can see that something changed on router 1, and this is a diff. So when you configure this type of diff, it's what you see on the output. This is the standard output, but there's also a diff that's saved as structured data that we can also use as code. So actually our playbooks can collect information, and that information can be, cached, and we create, other variables from it. But I won't go too much into that because we're going to really go into detail on that as we go through the study group. But this is just a diff to say that something changed. So this is what changed here. And what it's doing is it's configuring, it's taking what was in running config. So that's the before here. So this is in our running config because we went directly to that router and changed that description. And it's comparing it to what was the intended config. So the intended config did have a loopback 100, but it didn't have this description. So we can see that changed. So it's a failure because our policy is that you're not supposed to just be going and changing these routers. So that's where my notification was based off of a failure. It sends it, and then this is what actually changed. Now, if we were to change it back, it'll be in compliance. So in that case, it doesn't fail because it's just what we would expect to see in the intended config. So if I jump back into the router and change it back, which it didn't have a description. Oops, go into the port.
Hey, Tony, I think I missed this. What is the actual play doing? How's it grabbing the config from the device? Is it just doing like a show conf and parsing that, or how are you grabbing that config information with the play?
All right, so let me. I just wanted to just make sure that so it kicked off again over here, and bring this back up. See how I ran it again? It's okay. So we'll go to there in a second. So the whole thing with the config. So with that particular one, if I go into templates, you can see that we have this one right here, this config management. And it's pointing to this playbook here. So what we saw earlier is that controller 2 playbook was saying, okay, run this particular job template, which is this one. And then this job template is pointing to this playbook. So the playbook and how we did all that stuff is actually not in the Kafka repo. It's in this one, this compliance one. So if I go into these playbooks and go into config management, you can see that this is a like a typical playbook, but I'm loading a role. So I haven't talked, because we're so early into this, we haven't really talked about roles, but effectively roles are like purpose-built playbooks that kind of map to like a specific use case, and you can use them and make them repeatable, so that way you don't have to always put all this like detailed code in every playbook. You can just put like the variables and that type of thing, what's required, and then you can run the role. So the role itself is in here, and actually not that one, in task ILS. So here's what we did. So here is where we have some variables, right? So router item is the data that came in said that it was router 1. So just you can replace that there. And it's going to look for, like, see how it says diff against Cisco iOS configuration? So this is using what we call a config module. And a config module gives you the ability to use the intended config. So that's what I mentioned is kind of like just the terminology that we use in these modules to represent like the single source of truth. So if you have a config that's like, okay, here's the config, this becomes the intended config, then I'm able to use that and I can do a diff against it. So that was kind of the main magic there. And then the other piece for this is that I just want to iterate through, I could have more than one router that changed, that type of thing. And that's where, if there is a diff, then that's going to create that failure. And the fail is the notification that is sent from that. Or the failure creates a notification condition, right? And then that sends it to the Slack room. So this one's kind of a hard, since we're kind of early on, this is kind of a more complicated, role, but we're going to go through like all these in piece parts later. So it should make a little bit more sense. But this is actually like what happened behind the scenes, that last part of it. But does that make sense?
Oh yeah, no problem, absolutely.
So so that's there, and then I saw that it completed, so I just wanted to get back into it one more time. And our output's different this time, like nothing changes because we moved it back. We took away that description, so it's kind of like rolling it back to a config that now it like mirrors what should be the intended config. So it doesn't fail the second time. So it shows that it's remediated, and now we've reconciled that particular configuration. But this whole notion of like intended configuration is pretty straightforward because you're dealing with like config files, but it could also be databases and other types of solutions like ITSMs, and it could be like IPAM types of data you want to check against, like info blocks and all that kind of stuff. But at the end of the day, it always goes back to using diffs, is how you can see what the difference was between them. So when we get into the compliance types of things, we'll double click into that area. So this one was mainly around just getting started with the EDA part of it. So this deck will be available, and you'll have the link to both of these demos, both of these repos, and you'll be able to go and check those out. So that concludes the EDA. So I'm gonna go ahead and move around so I gotta remember to shut off this recording. But before I do that, does anyone have any EDA related questions?
What might be some ways to integrate rule books with a Cisco infrastructure or any network infrastructure for that matter? One of the demos that I saw for rule books they used webhooks to do that.
Yeah.
So I guess that kind of opens the idea to, using Teams or some other internal messaging platform to kick off events. But when you're dealing with just pure network infrastructure, what are some of the additional tools beyond using gRPC and Kafka and such? You have any thoughts on that? How we could integrate that with the network gear a little closer with minimal extra components?
Yeah, I was just checking this one out. I think I already removed the config for it, but I did another one of these, and I used. Are you familiar with EEM in Cisco devices?
Yeah, absolutely.
Yeah, so I set that up, and what I was doing was the same thing. Like you can go through that documentation, and there's all sorts of triggers. And one of the easier ones is like with
Oh,
syslog.
use traps. Okay.
Yeah, so anything on the router, right? So you can use syslogs,
Okay.
anything, command line. Yeah, so EM has all these different ways. So like someone does a particular command line, creates the event. So long story short, you create the event in EEM, and then you use the guest shell to run a Python script, and then in the Python script is for a webhook,
Mm,
and
okay.
in the webhook is whatever data you want to send.
Okay.
So I actually took I was going to show you the config here, but I removed it from this one. But I have a repo for that I think has the router config in it. But if it doesn't, I'll add it back into it. But that's another one where you don't have to use streaming telemetry. And to your point, really like anything else that has webhook capabilities, like the Nexus dashboard or any of that other newer stuff that has webhooks, then those could talk directly to the EDA.
Mm-hmm.
So it'll understand any webhook because it's just data. Now it also can understand like URLs, but I haven't done too much with it for like things like WebSockets and stuff. And like Eric had posted in the chat, like seeing something with ACI. That's how, like, from an ACI viewpoint, they don't have webhooks, but they have WebSockets. So that's another way. So
I
there's
think one of the other demos that I saw was related to using like Elk Stash, the Elk Stack.
Mhm.
Some event comes in syslog, and then it kicks off a webhook to run a play to go out and say remediate an access control list or something like that if a particular policy was violated, or a mean opinion score on a voice call was not what it should be. Just little things like that, and I thought that was a pretty powerful feature, but it wasn't real clear how you could kind of tie those pieces together simply. So
yeah, and it'll become a little bit cloudier too, because they created like this whole. It's just like open source everything else that we have. So anyone can create a plugin to be a source. So you'll see all sorts of new plugins besides Kafka and webhooks and everything else that's already there. I think we have like 5 or 6 of them right now. So you'll see that grow pretty quickly. The other thing we have is pretty cool one, and I need to switch over here, but we have our insights. So Red Hat has like insights for like mainly over like server types of things where, hey, you need to patch your server or something's not configured correctly. Those can become the events now. So it's like your server is out of compliance, from that viewpoint, and then it tells Ansible to fix it. So there's all sorts of, non-network use cases, all sorts of cool stuff's happening. But like, from my interest level, it's mainly around like the webhooks and WebSockets and Kafka and telemetry and all that kind of stuff. Cool. So let me if no one else has a question there, I'm going to go ahead and stop this recording. Stop the recording.